Let's try multi-criteria decision analysis, MCDA, and I'll show you how powerful it can be for environmental analysis. For example, let's examine forest health. Imagine a case where tall trees get sick and the sickness spreads from one tree to another. People need to address this issue, but how do we identify the sick trees on a map? Using our tools, we can do that. First, let's create a new analysis and name it Forest Health. We'll begin by adding the first layer, Forest Land Cover. As usual, we'll need to fine-tune it. Here you can see red areas, which represent regions with significant tree cover per hexagon, and green areas, which indicate little to no tree cover. Let's set the minimum tree cover to 80% of hexagon and exclude everything else from our analysis. Now only the relevant hexagons with forest cover remain. Let's zoom into a state, like Oregon, and add another layer, NDVI, Normalized Difference Vegetation Index. It measures vegetation health index from -1 to +1. We'll also add forest canopy height data. At this point, we can exclude the impact of areas with low forest, since it makes no sense to consider this factor in the final score. Let's take a closer look at the data. Here we have a forest canopy height of 15 meters, and the NDVI is around 0.8. In another area, the canopy height is 13 meters, and the NDVI remains strong. However, in some areas, the canopy height is lower, at 4 meters, and the NDVI is about 0.5. We can now adjust our parameters. Let's say we only want to focus on trees between 5 and 13 meters tall. We also need to adjust our sentiment index, since we are looking for tall trees with low NDVI values. Let's save these changes. Next, we'll refine our NDVI values. We'll set the minimum to 0.4 and the maximum to 0.7. After saving, you'll notice the red hexagons represent areas with low NDVI and high forest canopy, indicating something might be wrong in these areas. To further improve our analysis, we can modify the color intensities. If the NDVI falls below 0.4, the hexagons will appear redder, while those above 0.7 will turn green. Now we have a very interesting picture. Examining the numbers, pale green areas show a high forest canopy and high NDVI, which is ideal. Dark green areas indicate low forest cover, but still a high NDVI. Red hexagons, however, show regions with high forest cover, but low NDVI, suggesting potential forest health issues. With this tool, we've successfully identified areas where trees may be sick. This method can be applied in many different climate change, environmental, and resource management scenarios.